Hello everyone, welcome to video solutions of ANTHE 2019. I hope you will score good marks in this paper. We will start with Physics Class 11th Code E1, which was conducted on 20th of October 2019. So let's take the very first question. As you can see, the first question states particle has initial velocity of this value and a constant force of this value is acting on it. The path of particle will be. It is very evident, friends, when constant force acts on a moving object, only two cases are possible. One, the motion could be a straight line, and second, the motion could be a parabolic motion. So in the case of straight line, the force will be perfectly aligned with the velocity of the particle. That means force will be along the velocity, right? And here if you see the dot product of the two, let me solve that for you. So force is given as 2I cap plus 3J cap newtons, right? And if you see the velocity, it is given as 9I cap minus 6J cap meter per second. Now if you do the dot product of both, you will see that the value comes to be 0. That means they are not parallel to each other, instead they are perpendicular to each other. And in this case, when force is not aligned with the velocity, in that case only parabolic motion is possible. So answer to this question would be option 2. I hope you have understood the question very well. Now let's move on to our next question. As you can see, the second question states particle moves along x-axis as per the given equation, which shows it is performing SHM. Where x is the position, t is the time, and a being amplitude, it is constant. What we have to find is ratio of distance traveled by the particle in first second and second second, right? Let's start with the solution. If you understand it, as per the equation of x is equals to a sine pi by 6 into time, you can see the omega is pi by 6. Therefore, time period would be 2 pi by omega. That would be 12 seconds, right? Now, if you try to understand the motion of the particle, it starts from here, then it moves like this, and then this. So this is a representation where the time here would be 3 seconds, starting from the mean position 0. Here is 3, then it comes to 6 seconds here, 9 seconds here, and then at 12 seconds back to the mean position. So when you talk about the first second and the second second, definitely this would be somewhat where it would be at first second, and this would be somewhat it would be here at the second second, right? Now let's take this value as y1 and this distance here as y2. So we need to find y1 and y2. So if you want to find y1 would be simply a sine pi by 6 into 1, which would be a sine pi by 6, or what is pi by 6? That is 30, right? Similarly, when you talk about y2, it is at time 2 seconds, so a sine pi by 6 into 2. This would be a sine 60. Now remember, y1 and y2, they are the position of the particle from mean position. If you want to find the distance traveled in first second, so if I say S1 would be equal to y1, and S2, distance traveled in second second, would be y2 minus y1, right? And simply S1 upon S2 will be written as y1 upon y2 minus y1. Solving this, you will get a sine 30 divided by a sine 60 minus a sine 30. So if you solve this, what you will get is S1 upon S2 would be equal to 1 upon root 3 minus 1. So as per this, we can find what is the answer among the 4 options. You can see here option number 4 is the correct answer to this question, right? Now let's move on to our next question, that is question number 3. Here there are two particles A and B of different masses m1 and m2, and they are moving under the mutual force attraction F, right? Now force on A is F, which is applied by B, and force on B is F in the opposite direction. That's why it is given minus F, which is being applied by A. the acceleration of A relative to B is given by. So let's see the solution. It's a simple question, friends. Let's have two masses m1, this being m2. Force on m1 is F, so force on this would be F in opposite direction. If you write acceleration of 1 or A, that would be F upon m1. If you write acceleration of B on a vectorial form, this would be minus of F divided by m2. Now if you want to find the relative acceleration, you have to do that. Acceleration of A with respect to B will be written as acceleration of A vector minus acceleration of B vector. When you put down the values, you will get F vector by m1 plus F vector by m2. Right, friends? Now if you just see, you will simplify this to F vector divided by m1 m2 whole divided by m1 plus m2. Now let's see which is the best suited option here. Among the four options given, yes, option number 1 is the correct answer to this question. Now let's move on to our next question, that is question number 4.